Hello, this is Mrs. Henry, and these are notes for our Introduction to Oxidation and Reduction. A reaction in which electrons are transferred from one substance to another is called an oxidation-reduction reaction. Or, a shorthand way to say this, these are also called redox reactions, which is short for reduction and oxidation. And redox reactions are the topic of this unit. Oxidation involves the loss of electrons, and in these reactions, electrons are products, while reduction involves the gain of electrons, and in these reactions, electrons are reactants. I have a mnemonic that I use to remember this, and that is oil rig, where oil stands for oxidation is loss, and we are referring to electrons. Rig stands for reduction is gain, and again, we're talking about gain of electrons. Reduction and oxidation half reactions always occur simultaneously. That's because in one, electrons are products, and those electrons have to go somewhere. They go to the other reactant, and so the reactions, the reduction and the oxidation, always happen together. When one thing is oxidized, something else has to be reduced. Before we can learn more about this type of reaction, we have to talk about oxidation numbers. And oxidation numbers it's a number assigned to an atom or ion to indicate its degree of oxidation or reduction. And we're going to learn 7 different rules for assigning oxidation numbers. And I'm going to go through them here, and then we're going to look at some examples on how we apply these rules. Number 1 says the oxidation number of an uncombined atom, that means an element in its elemental form, is 0. So here I have 4 elements listed. You can see that iron is a solid. That means that it is iron metal, and that is the elemental form, so its oxidation is 0. Bromine is a liquid, and it's diatomic. This is the elemental form, so its oxidation number is 0. Sodium is a solid. This is sodium metal. Its oxidation number is 0. And then oxygen, another diatomic element that is a gas, that's the elemental form, has an oxidation number of 0. The oxidation number of a monatomic ion is equal to the charge of the ion. So here I have written the same 4 elements that we looked at before, but now these are all ions. And the iron plus 2 ion, since the charge is plus 2, the oxidation number is plus 2. Bromide ion has a charge of minus 1 because it's in group 17, so its oxidation number is minus 1. Sodium is an alkali metal in group 1. When it is an ion, it has a charge of plus 1, so its oxidation number is plus 1. And oxygen ion is minus 2 because it's in group 16, so the ion form of oxygen has an oxidation number of minus 2. Rule number 3 says the most electronegative element, and hopefully you remember that that is fluorine, is always assigned an oxidation number of minus 1 in compounds, and in compounds is important. So here we have the compound sodium fluoride, The oxidation number of fluorine in sodium fluoride is -1. When we have a covalent compound where fluorine is bonded to oxygen, again, the fluorine is in a compound, so the oxidation number of the fluorine is -1. But when fluorine is F2, that is the elemental form of the fluorine, and it has an oxidation number of 0 because it is the elemental form. Rule 4 states, in compounds, oxygen has an oxidation number of -2, which will be the vast majority of the time. Exceptions to this are in peroxides, where the oxidation number of oxygen is -1, and in compounds where oxygen is bonded to fluorine. Since fluorine is more electronegative, in those compounds, oxygen will have a positive oxidation number. This rule is important because when we assign oxidation numbers, many compounds have oxygen in them, and we can start with oxygen and assign an oxidation number of -2 most of the time. So oxygen is usually -2, except when you find it in a peroxide. These are the only two peroxides that we see in first-year chemistry: hydrogen peroxide and sodium peroxide. And in these compounds, the oxygen has an oxidation number of -1. The oxidation number in oxygen difluoride, though, is +2. The fluorine has an oxidation number of -1. The fluorine is always given the oxidation number first. Number 5 says, in compounds containing hydrogen, hydrogen has an oxidation number of +1 when bonded to a nonmetal, which will be most of the time. And the oxidation number of hydrogen is -1 when bonded to a metal. We don't really see compounds in first-year chemistry where hydrogen is bonded to a metal. There is one listed here. Hydrogen in the compound sodium hydride is -1 because the hydrogen is bonded to a metal. Most of the time, we see hydrogen covalently bonded to a nonmetal. So here, in water, hydrogen has an oxidation number of +1, and the oxygen is -2 because it's oxygen in a compound. Other halogens, and remember the halogens are group 17, except for fluorine, so we're talking about chlorine, bromine, and iodine. These halogens have an oxidation number of -1 in most binary compounds. And remember, binary means compounds with 2 elements. But when these elements, chlorine, bromine, and iodine, are combined with oxygen in a polyatomic ion, they will have positive oxidation states. And we will look at one of those in a few minutes. The last rule says that the sum of the oxidation numbers for an electrically neutral compound must be 0. The charges have to add up to 0. The sum of the oxidation states for a polyatomic ion must add up to the charge of the polyatomic ion. So there are some examples on the bottom of this page and on the top of the next page. I'm going to do 2 of these for you, and then I'm going to ask you to turn off the video and do the remainder. So A here is disulfur trioxide. And when I see this is a covalently bonded compound that has 2 sulfurs and 3 oxygen. I'm going to assign oxygen as -2. It's usually easy to assign oxygen first, since the vast majority of the time it's -2. But when I do this, I have to remember that there are 3 oxygen atoms, and each one has an oxidation number of -2. And so we have a total of -6 oxidation numbers in that compound. And so when I look at the sulfur, I know that in order to for all my oxidation numbers to add up to 0, which they have to do according to Rule 7 above, my oxidation numbers for sulfur have to add up to +6. And the +6 has to be evenly divided between the sulfur atoms. So each one has an oxidation number of +3, but I write the oxidation number for sulfur is +3. I don't add them together when I assign oxidation numbers. It's understood that you would add them together. You just always write the oxidation number for one atom. The other one that I'm going to do for you is letter C. This is a polyatomic ion, and the charge here is important. When I add up my oxidation numbers of a polyatomic ion, they have to add up to the polyatomic ion. So these will have to add up to -1. Again, I'm going to assign oxygen first. So oxygen is -2. And I have 3 oxygens again, so that will be -6 for a total for oxygen. And the nitrogen will be a positive number, and it will be a number that when added to -6 gives me an answer of -1. So nitrogen has to be +5. Okay, please do the rest of the problems. Turn off the video first, and then come back and check your answers. Okay, hopefully letter B was fairly easy for you to do. Oftentimes people get stuck on letter D because they're not sure how to combine all the rules above. I pretty much always assign oxygen first, which will be -2. And when I look at this compound, I know that this is an ionic compound that has 2 ions, a potassium ion and a chlorate ion. I know that potassium is a monatomic ion that is in group 1, and because of that, the potassium is +1. That is rule number 2. And then I have a chlorate ion here, and I'm going to add up my oxidation numbers from -6. And when I add 1 for the potassium, that will be -5. So in order to balance the -5, my chlorine has to have an oxidation number of +5. Moving down to the next page, most people have no problem with F or G. Chromium, this is chromium ion, so the oxidation number is just the charge of the ion. Calcium perbromate often causes an issue. But again, if we divide this into ions, I see that I have a calcium ion. Calcium is a +2 ion, so it is a +2 oxidation number. It's +2 because it's in group 2. And if I assign oxygen as -2, which I should do, then I can figure out the bromine. And since there's 8 oxygens, one way to do this would be to add up all the negative charges and add the 2. But there's another way to do this too. You can just look at the perbromate ion, and you should have memorized that that is a -1 charge. And then I have 4 oxygen atoms. Each is -2 in oxidation number for a total of -8. And then I have 1 bromine, and the oxidation numbers have to all add up to -1 because the charge on that ion is -1. So my bromine oxidation number must be +7. That concludes this section of the notes. Thank you for listening.